G'day, it's Alex here, Victor Kilo 2 Papa Radio Charlie. On the repair bench, I find another Clansman, one that's been sent to me by a friend, Colin, Victor Kilo 2, Juliet Charlie, who's got a typical problem that many people out there have, and like many people, Colin hasn't been able to fix this one, and he's asked me for a bit of advice. He tells me that he bought this particular radio, it operated okay for a while and stopped transmitting. He sort of tracked the problem down to the relay in the turret that is the changeover between receive and transmit. Changed the relay, thought he had it all fixed, and still it won't work. So in fact it's a dead set. It just sits there and looks at him, doesn't make any noise at all. And I think it's not only Colin out there that's got sets like this. There's many people that have sets that have problems with receive or transmit. I read on the forums, I see on email messages that people are continually saying, I was using my radio and it just stopped, now it doesn't transmit anymore, what's the problem? There are people out there that give advice, and it's all good advice, like your transmit receive relay could be broken, might need changing, the problem could be in the turret, have you tried your power supplies? All this sorts of advice comes pouring in, and in many cases people find themselves with a radio that they can't fix, and it ends up sitting on a shelf, becoming a doorstop, or perhaps being rendered to a spare set. So what I'm going to try and do here today is explain exactly how the Clansman radio operates between transmit and receive, step by step, and where the things are that move and where the things are that don't, how it all works, what the typical failure is, and where to look for it, how to test it, and how to repair it quite easily. So before we go on to the radio, let's just pull up a diagram of how all this works, because once you understand how it works on the diagram, it makes it a lot easier to start working on the radio. Let's have a look at the diagram. Okay, what I've done here, I've actually put together a simplified line diagram of how the Clansman receive and transmit changeover relay setup operates. And yeah, so what we're going to do, we're going to go through all of this little diagram and see how it all operates, and then we can understand how the radio changes from receive to transmit and vice versa. Okay, so before we get into it, let's just identify all the parts we're going to be talking about. So this part over here, this is in fact a solid state fast switching on and slow to open device here that lives on the 1A board. Okay, so let's just go and have a look at that. So there's a 1A board there. In fact, it's been pulled out, but it lives just in there behind the synthesizer. And on this part of the board here, that's where that little part of the circuit lives, right there. Okay, just again, it's a solid state switch that's fast to close and a little bit slow to open. Let's move along now to the back section of the board, the 2B. That's a little board that lives on the back section of the Clansman radio, and inside the 2B board there's a relay, and it's the main transmit receive changeover relay. It's right there. There's the coil and there are the contacts. So let's have a bit of a look and see where we'll find that. So looking at the back section, it lives inside there. Two little screws off there. You can take that plate off and you'll see it inside. It's a little metal rectangular relay. Okay, so mechanical relay that lives in the 2B section. Okay, now there's three relays in the Clansman radio that change from transmit to receive and vice versa. There's another one here that lives in the motherboard, which is this number 6 board, and that's the main board that lives underneath. If I was look on the bottom, that's the number 6 motherboard, and that's where that particular relay lives. The third relay lives in the turret, in the 3A in the turret, and this changes over again the receive to transmit of the turret. And if you look here, you'll see there's a little rectangular cutout down here. See if I can find it. Little rectangular cutout right there, and that's the relay inside that cutout. That's the third of the three relays that change over. Okay, so what we're going to do, we're going to have a look at how these relays operate and what goes wrong. So let's do that next. Okay, I would suggest you freeze the video here and do a screenshot. That'll give you a good memento of my diagram. Okay, right, let's go on and explain how all this works. Okay, right, so it all starts at the battery terminal. That's the battery terminal. Well, we know where that is on the Clansman. That's the plus battery terminal. And you're going to be surprised to learn that when you put a battery onto the Clansman radio, even though the radio's turned off, there are parts inside the set that are alive. Right? The first thing is a terminal over here on this little board 1A, and that happens to be terminal 11. That'll be alive at 24 volts even though the set's turned off. Also, the contact over here on the 2B board is alive as well, okay? And this particular line is called 24 BAT, obviously, because it's connected to the battery. Okay, so there you go. You connect the battery to the radio and the 24 volts is applied to those terminals and it just sits there. Okay, all good. The next thing is we turn the radio on. So if we turn the radio to ant, low power, high power, whatever, we actually put 24 volts on terminal 13 on this little circuit that lives on 1A. We also put 24 volt SW, which is 24 volts switched. We put it to the relay on the 2B board, which is the back board. Now, the relay doesn't pick up because this side of the relay is sitting there with a high voltage on it as well. So both sides of the relay have 24 volts on them, and that 24 volts is generated from the motherboard. Okay, so the relay sits there and doesn't turn on. Okay, so we've just go again, we switch on, we got power to this part, the solid state switch, and we got power to the relay as well. But the relay is not going to pick up because both sides of the relay are sitting there at 24 volts. Okay, now before we go on, interesting thing here we've got to see is we've got to notice that the solid state relay, and that's one terminal of the solid state relay, and that's the other terminal of the relay. When you follow those lines, that side goes to one side of the mechanical relay in 2B, and this one goes to the other side of the mechanical relay in 2B as well. So the mechanical relay in 2B contacts are in fact in parallel with the solid state relay living in 1A. Okay, the only difference between the solid state relay and the mechanical relay is the speed at which they operate. The solid state relay operates very quickly, much faster than the mechanical relay. Interesting. So let's just go through now what happens when we push the PTT. So down here on a board, on the motherboard, 6D board, this is where the signal from our PTT gets into our relays for our radio. As soon as we hit the PTT, coming out of 6D, terminal 10 goes low, goes to 0, or pretty close to 0. And what it does is two things. By going to 0, it switches on very quickly the fast-acting solid-state relay, and it grounds the other side of the coil, the mechanical one, in 2B. And this picks up as well. So we've got two things happening. The solid-state relay closing instantly, and fraction of a second later, the mechanical relay closing. Why is this, you think? Well, I'll tell you exactly why it operates like that. It operates like that to save the contact arcing, because this solid state relay takes the inrush of current when we first transmit, which happens to be 4.5 amps, instead of the contacts on the relay. So the solid state relay closes first, takes the inrush of current. The mechanical relay closes a fraction of a second later, and there's no arcing on the contact. Pretty smart. It's called contact saving or contact life extension. Okay, so we're happily transmitting away, and we decide to take our finger off the PTT and go back into receive mode. Well, as soon as we take our finger off the PTT and go back into receive mode, terminal 10 in 6D goes high, so it goes back up to 24 volts, which has two results. The first result is it switches off the solid state relay, so this opens up again, and it de-energizes the coil on 2B because it puts the same potential across both sides of the coil, and there's no resultant voltage across the coil, so it drops out. But the interesting thing is, again, the speed at which each of these drop out differently than when they picked up. Because the way that this is designed, this hangs in for ever so slight amount of time, yeah, allowing the mechanical relay to open while this still remains closed, and the relay opens without arcing. Soon as it opens, the solid state relay opens and we get no arcing on the contacts on 2B. So in summary, the solid state relay closes before and opens after, allowing the contact in 2B to open and close without arcing, which extends the life of the relay, well, so much more that it becomes a military standard radio designed not to break down and operate many, many times, especially for Morse code, because this little relay would be rattling away like you wouldn't believe when fast Morse is being transmitted. And you can imagine the burning contacts that aren't happening because of our wonderfully designed little solid state relay over here. Okay, but unfortunately all good things don't always last forever, and bad things happen. So let's start talking about the eventuality of bad things happening and what actually happens and what we've got to do to fix it. Okay, bad things are about to happen. Here we go. We're out working with our radio, making all sorts of these fantastic DX contacts because we all have Clansman 320s that do it so well. And all of a sudden, the mechanical relay here that's operated for zillion times decides that the little spring has just about had it, metal fatigue, and it fails. Okay, so we found our contact either stays frozen on or stays frozen off, or yeah, one of the two. And our radio stops working, okay? So what actually happens is that when this relay here stops operating, all of the load for transmit and receive gets reflected back onto the solid state relay. And the solid state relay is not really made for extended use because the little transistor here has a maximum current of 5 amps, but only instantaneous current. It's not it's not long-term current. So any sort of long-term current through this transistor and it will fail. So if the relay fails, and we just can't believe it, and we keep pushing the PTT, what's going on here? This is my wonderful Clansman radio that never fails. What's going on? I'm checking antennas, I'm banging it, I'm kicking it, I'm doing all sorts of stuff to make it go again, and I keep pushing this button. All I'm doing is loading up, and finally causing this part of the circuit to actually fail. Okay, so we'll go on to the failure mechanism in a few minutes. But once this part of the circuit has failed and this part of the circuit has failed, no go, no more, which is unfortunate. So many people hear the heed of people that give advice, and they say, oh, you've got to have a look at your relay here. It could be a problem, and because it's the main transmit receive relay and it's probably at fault. So in many cases people will change the relay here, unsolder it, put a new one in. They are available eBay in the UK. I think they come from Italy, to tell you the truth. But anyway, as soon as they put this on, this part of the circuit has still failed. Consequently, the radio may not operate at all and end up like this particular one on my bench. Or if the radio operates at all without the solid state part of the circuit, the contacts on here quickly fail because they're arcing on closing and they're arcing on opening, and the relay doesn't last long at all, and the radio soon becomes another one of those door stops again. Okay, so let's have a look at what we can do when this happens to us, and what sort of testing we can do, what goes wrong, and how we can fix it. Okay guys, let's have a look at the relay that lives inside here. And this is the one that usually fails when you transmit and receive buggers up. Okay, so if you want to know how the pins here are numbered, on this side here, that one there, that's number 1. It goes up to number 7, and then number 8 starts down here again and goes up to whatever. I think it's 15 or something, doesn't matter. So when we look on the diagram, we'll see that the coil is in fact 5 and 6, and the contacts are in fact 10 and 12. So the way that I test the little relay here is I'll grab a 24 volt Clansman battery, put a couple of alligator clip leads on it, and clip those leads onto the test leads on my multimeter, and very, very carefully use the test leads on the pins here to energize the coil of the little relay, this one here. So I'll very, very carefully put my test leads with 24 volts, and I'll apply 24 volts plus to the 6 terminal and the other side of the battery to the 5 terminal. And I should be able to hear the relay going click, 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 click as I touch those 2 pins. Remember, the pins start number 1 and go up this way. So count up, 5 and 6, they're up here somewhere, and yep, get your probes, put them on there, and with 24 volts applied, click, 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 click. But just because you're hearing click, 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 click doesn't mean that the contacts are making. So what you should do is monitor the terminals 10 and 12. So get yourself a couple of little leads, and with some very, very small little clips, put them on pin 10 and 12, and put that to a meter on ohm scale. And as you energize the relay, you should be able to see on your ohm meter, you should be able to see the contacts closing and opening as the needle swings on the ohm meter from a short circuit to an open circuit. That way we can test the relay on 2B right here without pulling anything apart. Okay, so it's a pretty easy test. Takes only 10 minutes with the right little test leads. Okay, the next thing that we want to do is test our solid state relay. Okay, now before we get started, there's a certain bit of a giveaway here if we've got problems. Remember when I said that pin 11 is alive when the radio is turned off? So the first thing you should do is connect the battery on the radio, and take the cover off the radio, put the 2 halves back together, and let it sit there open and turned off. Grab a meter and test pin 11. Pin 11 should have 24 volts because that's connected to the battery. Pretty easy. And here's the interesting thing. Pin 10 should in fact be 0. If the transistor is shorted, there'll be voltage on pin 10, which will be a warning, Ward Robertson, warning, warning, that's a problem. And you'll probably find that not only will 10 have voltage on it, but in fact 13 will have voltage on it, and pin 12 will have voltage on it as well, which is all wrong, because with the radio turned off, it's only supposed to have voltage on, hang on, we've got a bit of a problem with the focus. It should only have voltage on 11. These other terminals should all be 0. Okay, so number 1, if you've got voltage on any other of these terminals, you've got a problem with the solid state switch. And number 2, if you're connecting a battery to the radio and finding that the battery's going flat over time, even though it's turned off, you've got a problem with the solid state switch. So let's have a look at that. Okay, I've got this board unscrewed from the chassis. It's dangling around here because I'm changing components on it, doing this repair. But this terminal here is your 13, 12, 11 and 10. So they're the terminals there that I've been talking about that you need to be monitoring to find out if the voltages are in fact correct when you have the radio turned off. Okay. So if any of those other terminals besides terminal 11 is in fact energized, you've got problems on the solid state. And chances are, if you've had a relay failure here, you're going to have a solid state switch failure here as well. So you should definitely do a maintenance check on this part of the circuit. So let's have a look in detail at what goes on in this solid state part of the circuit. Okay, here's our little arrangement for our solid state switch. Okay, so there you go. Pin 11 comes in from the battery, should be alive all the time. Pin 10 should be dead with the set turned off. 13 should be dead with the set turned off, and 12 should be dead with the set turned off. So when this part of the circuit fails, it usually fails like this. You'll find transistor shorted. And by the way, this is one of these super duper transistors that only seem to pop up on Clansman radios. A tiny little thing like it is, and it handles 4.5 to 5 amps instantaneous current. Just absolutely remarkable, but I haven't been able to find a substitute, so you're probably looking on eBay UK for a replacement, and they are available there because that's where I get mine. So you'll find that this transistor here is shorted. In many cases you'll find the diode in fact here is shorted as well. And lastly, this resistor R7 is usually cooked. So you'll find 3 of these components at least that have failed. But in saying that, you should definitely be checking this transistor as well for a failure as well. So yeah, that's generally what goes wrong with this part of the circuit, and generally what you should be looking at to fix it. So there's only a handful of components in this solid state switch, and I would suggest you check every one of these little components. But just going on historically, the sets that I've repaired, it's always the same. It seems to be this one, and this one that causes the failure. And of course, the way to do that is to remove the board. I think the last particular repair I did, I took all of the terminals off to do the repair and did the repair on the bench, but this time I've got a little bit lazy and I've left some of the terminals on, and I've moved the synthesizer out into the service position by going underneath, taking the motherboard off and relocating the screws. You'll see there's some green indicators how you move this out and re-screw it back in again into the service position, and gives you a nice bit of space behind the synthesizer. Take the 2 mounting screws out, and there's half a dozen wires that you take off there, and it allows you to get it up and get it, into a situation where you can desolder the dud components and do your testing. So at the moment with this particular one, I'm in the stages of waiting for a replacement transistor from the UK. But as soon as I get that transistor, I've already changed the resistor and I've already changed the diode. So yeah, I would expect that, and I've done the relay here as well. So I would expect the set to come back to life without a problem, unless it's got some other issues that we would move on to. Oh, I almost forgot to mention, there's another dead giveaway that that you've got a problem in the solid state relay, is when you connect the battery onto the Clansman with the switch turned off, you can hear a relay picking up on the board. You disconnect the battery and you reconnect it again, it goes click, 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 but yet the set's turned off. That's a dead giveaway that transistor in the solid state relay is in fact shorted. Yeah, and this particular set here that I'm repairing, this was the dead giveaway that gave it to me. As soon as I connected the battery, I heard it straight away. Click, 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 and I knew straight away problem was on the 1A board solid state relay. That's basically the story of the failure mode that these particular sets have with their relay system from receive to transmit and from transmit to receive. And if you happen to have one of these sets that that has failed in one of these ways, I would suggest you well, fix it, because it's not that difficult, to tell you the truth. Not that difficult once you know how. And after hopefully this little video is explained to everybody on just how all of this little bit of circuit trickery works, why it works, and yeah, and where to find it. Good luck, guys. This is Victor Kilo 2 Papa Radio Charlie. Alex here, over in Australia, about to jump in the car and go and do some DXing. Catch us all again, 73.